In this video, I'm going to cover how to adjust nozzle and throw diffuser coefficient of a jet pump in Whitson Plus if you have any manufacturer data. So when you acquire your jet pump or when your manufacturer is doing the design of the jet pump, they typically provide a sheet that looks like this, a summary sheet. And here you have some information about the well, like GOR, water cut, and what kind of fluids it's producing, what are the operating conditions, wellhead pressure. But then here, after that, you see here the type of pump that it's using. And here you have some operational conditions. In this case, we have 5 conditions. So here you have liquid rate, you have the power fluid surface injection pressure, you have the power fluid rate, and then you have the pump intake pressure. So when we in Whitson Plus, we have some default coefficients that are used, the nozzle and the throw diffuser coefficient for the performance of the jet pump. And if you use those, they might not always match the manufacturer conditions that are shown here. So our main purpose is going to be to upload this data to Whitson Plus and then to see what suction pressure we obtain. And then we need to adjust those coefficients to get a better match with the manufacturer values. So we have this case. It's going to be, besides all the information that was shown before, GOR, water cut, and temperatures and fluids, here we have a well. It's a vertical well down to the jet pump. 9,040 feet is located the jet pump at that place. And then we have top perforation much deeper. And we have flowing, the flow of after downstream the jet pump is flowing through the annulus. The power fluid is injected through the tubing. And then we have flow of the reservoir fluid through casing and tubing. But very important, for this purpose, we're only going to model the well down to the suction of the pump. So we're going to just include the pump, and then we're going to include a short piece of tubing, 2 feet, and that's where we're going to read the pressure, and that will be the suction pressure of the pump because that's the value we have from the manufacturer. So I have done. So first, yeah, then we have the production data. Production data have extracted the data that is shown here, and I put it in this table format that I'm going to input in Whitson Plus. So here you see these are 5 points, and these are these 5 points there. You have oil, gas, and water rate, gauge pressure. That's this pump inlet pressure that is reported by the manufacturer. Yeah, the casing pressure is taken from the main sheet, and then here you have the power fluid rate and power fluid pressure. But I also, because Whitson Plus makes 2 different calculations if you provide the power fluid rate or if you don't. If you don't, then it has to estimate it. So it's using also the throat and diffuser coefficient. So I just simply duplicated all of the points, but these operational points, when I remove the power fluid rate. The first block is going to allow us to adjust the nozzle coefficient, and the second block is going to allow us to adjust the throat diffuser coefficient. Okay, so after I load the data, then I go just show you here how is the well information. If you see here the well, it exists. So the top perforation is at 9,042. I'm assuming like the well ends exactly at the suction of the jet pump. And when I enter into the jet pump, I'm flowing. The production fluids are going through the annulus downstream the jet pump. And the jet pump is located at 9,040 feet, and then D plus 7 from Whitson. And here you see the coefficients that we're going to adjust. So first, let's use these values, which are the default. Then we run. And this here you see the first 5 points. The match is actually not bad at all. It's quite good. But here the match without power fluid rates is a bit is not perfect. Okay, you have some differences. So what you have to do is you have to adjust. Let's adjust a little bit the nozzle coefficient, so just to prove the point. Even though in this case might not be that necessary. So I change it to 4, increase it. Okay, and then I rerun. And now you see the pressures before they were above, and now they are slightly below. Okay, but they are closer. But now you see this mismatch. So to close that mismatch, then I have to change the throw diffuser coefficient. Let's try with 1, for example, 0. To make it half. Now it's a bit closer, but I think I can do better. So I can actually change it to 0. Maybe half of that. Okay, and now it's actually quite a decent match. So after you do this, with some manufacturer data, your Whitson Plus results should be more accurate because you should capture better the performance of the pump. Bye.